Hi everyone, and this is Sharan Kumar from EC Department, BVC Engineering College, Vadal. So today we are discussing about the concept of Bi-CMOS technology in the stream of VLSI. So coming to the today's contest, what we discussed today, the list is introduction, abstract, characteristics of CMOS technology, characteristics of bipolar technology, combine advantages in Bi-CMOS technology, Bi-CMOS fabrication process and Bi-CMOS integrated circuits, advantages of Bi-CMOS transistors and disadvantages of Bi-CMOS transistors and applications of Bi-CMOS transistors, and comparison between CMOS and Bi-CMOS products, the list of different Bi-CMOS products, and finally conclusion. So coming to the introduction and the history of semiconductor devices, started in the early years of 1930s. Bipolar technology was started in the year 1980s, and similarly the CMOS technology was also started in the mid of 1980s. Later in 1990s there was a crossover between bipolar technology as well as CMOS technology. In Bi-CMOS technology, both MOS and bipolar devices are fabricated on a same chip. That means previously we have bipolar transistors BJTs and similarly MOS transistors like NMOS transistor, PMOS transistor as well as CMOS transistor. Each one having its own features. Now has to be go with the combined features of bipolar transistor as well as CMOS transistor that should be available in Bi-CMOS transistor technology when we can combine MOS transistors as well as bipolar transistors. And coming to the objective of this bipolar CMOS transistor is to combine bipolar and CMOS transistor. As we exploit the advantages of both the technologies in the same transistor. Today Bi-CMOS has become one of the most dominant technologies used for high speed, low power and high functional VLSI circuits. The process step required for both CMOS and bipolars are similar. The bipolar CMOS transistor, process has same been enhanced and integrated into the CMOS process without any additional steps. That means the same process is needed for the Bi-CMOS transistor as the same as CMOS transistor as well as bipolar implementation. And the primary approach to realize high performance Bi-CMOS devices is the addition of bipolar process steps to the baseline CMOS process. The Bi-CMOS gates could be used as effective way of speeding up the VLSI circuits. The applications of Bi-CMOS transistors are very wide and vast applications. In many applications we are using Bi-CMOS transistors nowadays, and all these applications we can discuss in the later slides. And coming to the advantages of bipolar and CMOS circuits can be retained in Bi-CMOS chips. That means each bipolar transistor having its own advantages and CMOS transistors also having its own advantages. Now it has to be combined the common advantages as well as the individual advantages of bipolar transistors and CMOS transistors into the Bi-CMOS transistors. And finally, the Bi-CMOS technology enables high performance integrated circuits, that is nothing but ICs, but increases the process complexity. By using this Bi-CMOS technology we are improving the speed, but the complexity of designing should be is also be very more. And coming to the what is the abstract of this Bi-CMOS technology, and the Bi-CMOS technology is a combination of bipolar and CMOS transistor technologies. And CMOS technology offers the less power dissipation, smaller noise margins and high packing density. Coming to the point of view of CMOS technology, it offers only less amount of power. And coming to the high packing density, that means by using the CMOS technology we can able to place very more number of transistors in the same IC. That is approximately around millions of transistors we can able to place in a single IC. And bipolar technology, on the other hand, ensures high switching and I/O speed, input output speed, and good noise performance. That means the speed should be more as compared to the CMOS technology. The bipolar technology having speed. Now we are in the third generation of BiCMOS technology. And coming to the BiCMOS technology accomplishes both improved speed over CMOS and lower power dissipation than the bipolar technology, simply by combining of both, so CMOS and bipolar technology. The main drawback of BiCMOS technology is the higher cost due to the added process complexity. That means individually for the implementation of bipolar technology has to use the process of bipolar use only. And coming to the CMOS implementation, we are using the fabrication process only for CMOS only. So coming to the combination of these both bipolar and CMOS, it has to be used both bipolar fabrication process as well as CMOS fabrication process. The number of steps are also be increases, then the complexity is also be more. And coming to the this greater process complexity in BiCMOS results in the cost increase compared to the conventional CMOS technology. And coming to the characteristics of CMOS technology, what are the characteristics? We can list it all the characteristics of CMOS transistor technology as well as BiCMOS in the next one. And coming to the characteristics of CMOS technology, so lower static power dissipation and higher noise margin and higher packing density. That means we can able to place millions of transistors in the single IC, and high yield with large integrated complex functions. And coming to high input impedance with low drive current. And coming to the scalable threshold voltage, that means very limited threshold voltage have, and high delay load sensitivity and low output to drive current. And coming to the low transconductance, an important point is it is a bidirectional capability. So coming in the CMOS technology, we have drain, source and gate. Coming to here, the source and drain, so both are interchangeable. We can use in drain as a source as a drain. That's why it is a bidirectional capability. A neo ideal switching device and low gain. And coming to the characteristics of bipolar technology, it is higher switching speed as compared to the CMOS. So CMOS having less in speed, switching speed, and coming to the bipolar having higher switching speed and higher current drive for unit area, and also be higher gain. And generally, so better noise performance and better high frequency characteristics in bipolar technology. Improved I/O speed and higher power dissipation, that is the drawback in this bipolar, that should be overcome in CMOS. Okay, lower input impedance and lower packing density. Okay, as compared to the CMOS, it has higher packing density in CMOS. Coming to bipolar technology, it is low packing density. That means it is less number of transistors you can place in that, and low delay sensitivity to load, and high transconductance, that is M. It is essentially unidirectional. That means you can use only one direction. That is, so base terminal should be acts as a base, gate and collector terminal should be acts as a collector only, and emitter terminal should be act as a emitter only. We are not able to interchange the terminals. But coming to the CMOS, both the drain and source can be interchangeable. That's why that's called bidirectional, and this is one called unidirectional. Coming to the combined advantages in BiCMOS technology, it follows that BiCMOS technology goes somewhere towards combining the virtues of both CMOS and bipolar technologies. Improved speed over purely CMOS technology, because CMOS technology having speed is less. That's why it has to be go with BiCMOS bipolar technology speed, and lower power dissipation than the purely bipolar. Bipolar technology required high power dissipation. Here the low power point can be considered from the CMOS technology, and flexible I/O for high performance, and improved current drive over CMOS technology, and improved packing density over bipolar. In CMOS technology we have high packing density, that's why you can consider the high packing from CMOS technology as compared to the bipolar. And high input impedance, low output impedance, and high gain and low noise. And this is the the BiCMOS fabrication process. Simply we can observe, and this is the bipolar in two ways, that is plane view, that is top view, and this is the top view, and this is cross-sectional view. And simply we can observe here, in this case we are using the well process, that is we are using here N well, and this is purely P substrate we are using over here. This is the P substrate, and in this case in the well process we are using N substrate, and this is P substrate, and see here, and this is the diffusion we are using here, that is P diffusion for the base contact, and this is N diffusion for emitter and N diffusion for collector. Simply we can observe, that is from emitter, base and collector, N type, P type and N type, N diffusion, P diffusion and N diffusion. Simply it is a simply NPN transistor as bipolar. And simply observe here, in this case collector, emitter and base, this is the cross sectional view. Simply you can observe here, base is a P diffusion, emitter is N diffusion and collector is also be N diffusion, and this is P substrate which is used in the N well. And these are the some models for BiCMOS integrated circuits, and these are the simple models. And coming to the advantages of BiCMOS technology, improved speed over CMOS technology, because bipolar transistors having high in speed, more speed compared to the CMOS. Improved current drive over CMOS, and improved packing density over bipolar transistors, and lower power consumption than bipolar transistors, higher input impedance, low output impedance, and finally high gain and low noise margin. These are the advantages. And coming to the disadvantages, increased manufacturing process complexity. The complexity should be more as compared to the bipolar or CMOS. Coming to high cost, requires very high cost for the entire designing or fabrication. The speed degradation due to scaling, once you can scaling down these, the speed should be decreases, and longer fabrication cycle time. Simply you can observe, this is the fabrication cycle, and initially has to be go with bipolar process, after then it has to be create well, after then gate, oxide and poly, and finally CMOS process has to be combine all these for the formation of the BiCMOS transistor. Coming to the applications of BiCMOS transistors, okay, those are full custom ICs, and see here these are full custom ICs, and AL arithmetic logic units and barrel shifters, and SRAM and DRAM, static RAM as well as DRAM, and microprocessors and microcontrollers, and is also be used in semi-custom integrated circuits, and some of the very important applications in resistors, flip-flops and standard cells, and adders, mixers and analog to digital converters, digital to analog converters, and gate arrays, and finally flash analog to digital converters. Okay, now has to be go with the comparison between basic CMOS and BiCMOS transistors compared to in terms of speed, delay and area. And see here, as compared to the CMOS, BiCMOS having higher in speed as compared to CMOS. And coming to the delay, simply you can observe here, for the CMOS having high delay, coming to the BiCMOS having less in delay. And similarly here, as compared to area, CMOS having somewhat higher area required, for BiCMOS less area. These are the three comparisons in terms of speed, delay and area. Okay, these are the simple products designed for BiCMOS. And finally, thank you.